Hi everyone, this talk is about the UNLP 2023 shared task on grammatical error correction for the Ukrainian language. The shared task has been organized jointly with Mariana Romanyshyn. It was active from December 2022 till March 2023. Although it's officially closed now, the leaderboard is still active and you are welcome to submit your solutions. The goal of this task is to rewrite ungrammatical texts to texts free of any errors. Here you can see an example. We have an ungrammatical input, "Я йти до школи," or "I goes to school." The goal of the task is to produce the grammatical output such as "Я йду до школи" or "I go to school." The errors could be divided into four broad categories. Grammar errors include things like incorrect usage of case, gender, number, tense, and other grammatical rules. Spelling errors occur when words are, spelled incorrectly. Punctuation covers missing or unnecessary punctuation marks, such as commas, em dashes, or question marks, as in this example. Note that in the Ukrainian language there are more punctuation marks used compared to English, which results in a higher number of punctuation errors in the data. And finally, there's fluency that covers errors that have to do with style, calque, poor sentence flow, and other aspects that sound unnatural to native speakers. Fluency is a more subjective task and can be more difficult to correct. Our shared task has two tracks. The first track, GEC-only, focuses solely on grammatical, spelling, and punctuation errors and does not take fluency into account. Track number 2 is GEC+Fluency, includes all four error categories. Now, let's talk about the data used in the shared task. The shared task is based on the UAGC dataset. It contains 31,000 sentences for training and approximately 3,000 sentences for testing and evaluation. Validation and test sets are annotated with two annotators. This helps to somewhat compensate for the subjectivity of the task. If a correction is in agreement with at least one annotator, we count it as a valid one. We provide participants with lightly preprocessed data in three formats. First, unprocessed parallel text. Here we have the original untokenized data in two files, source and target. Source are texts that contain errors, and target are presumably error-free texts. Second format is tokenized parallel text, same as above, but this time we tokenize the data using the stanza tokenizer. And finally, we provide participants with M2 files. This format is commonly used in grammatical error correction tools and other shared tasks. In particular, it's used by Errand, which is a program that computes evaluation metrics. Participants were free to pick whatever format worked better for them. However, we evaluate results on tokenized data, and to help participants, we provide them with a tokenization and evaluation script. In order to utilize the document-level context, we kept the order of sentences as they appeared in the original document. We also added document headers before a sequence of sentences. This way, participants could use document-level context if needed, but they could also ignore it and work on a more common sentence-level models. So far, nobody has utilized the document-level context. The primary evaluation metric used for the shared task is the F0.5 score, which combines the precision and recall metrics while weighting precision more than recall. This metric was computed using the Errand tool. In addition to reporting the F0.5 score, we also report precision, recall, the number of true positive cases, the number of false positives and false negatives. These are all commonly used metrics in GEC evaluation. However, most of these metrics are provided merely for reference and are not considered while comparing the participating models. Okay, so on to the results. We have 15 teams that have registered to the task. Out of them, 6 have submitted a solution. Here you can see the results. Those results are also available on a live leaderboard. We will post a link on the last slide of this presentation. UNLP took the first place in the GEC-only track. Congratulations. And Pravopusnik took first place in the GEC+Fluency track, followed very closely by NLP again. Let's take a bird's eye look at what the submitted systems look like. We can see that most of the models are based on some form of pre-trained transformers. Only one system has been trained from scratch. The best performing systems utilized data augmentation techniques. Typically, they introduce synthetic errors to clean data by doing either back translation or round-trip translation, and also using spell checkers confusion sets for noising the data is commonly used. Most architectures are sequence-to-sequence models. There's only one sequence tagging model, and there's one seek-to-edits model, which can be seen as an inference-optimized seek-to-seek. Here are some fun facts for you. We have 15 teams registered for the shared task. Out of those 6 teams survived to making at least one solution. Overall, we got 261 submissions, and almost a half of those submissions we received on the last day of the competition. There are some limitations in this shared task. We plan to address them in the future. Perhaps the most important one is that the test set is rather small and can hardly be called representative. We plan to increase it in the future. Almost half of errors are punctuation errors. This is not a limitation per se, but it leads to scores that are inflated and are higher compared to, let's say, English GEC. Just something to be aware of. Finally, we're thinking about releasing an automatic error categories classifier so that the results could be analyzed per error category. Here are some useful links to the shared task. Note that the leaderboard is still active, so you're still welcome to participate. In conclusion, I'd like to thank all participants for making this shared task possible. Thank you, and we look forward to the next shared task. See you!